Hello, dear students. I'm glad to meet you at our course. Today we are going to talk about foundation. Let's start. All buildings have similar components such as foundation, plinth, walls, floors, doors, windows, and roofs. Every component has its own function. These building components are classified into two categories: non-structural components and structural components. Non-structural components are parapet walls, doors and windows, furnishings, fixtures, partitions or partition walls, tiles, paint, etc. Structural components or elements are the primary load-bearing components of a building, and each has its own structural properties which need to be considered. Such components are the foundation, plinth, wall and pier in the superstructure, shear wall, column, floor, slab, beam, roof, staircase, lintel, weathershade. The lowest part of a structure, which transmits the weight of the structure together with live loads and seismic and wind pressure to the ground surface on which the structure rests, ensuring its safe bearing capacity, is called the foundation. To increase the stability of the structure, foundations are generally placed below the ground level. The following are the main functions of foundations: to transmit and distribute the total load of the structure to a larger area of underlying support, to prevent differential settlement of the structure, to provide stability to the structure. Types of foundations. Very broadly, foundations can be categorized as shallow foundations or deep foundations. Shallow foundations are typically used where the loads imposed by the structure are low relative to the bearing capacity of the surface soil. Deep foundations are necessary where the bearing capacity of the surface soils is not adequate to support the loads imposed by a structure, and so those loads need to be transferred to deeper layers with higher bearing capacity. Types of shallow foundations include strip foundations or footings provide a continuous strip of support to a linear structure such as a wall. Trench fill foundations are a variation of strip foundations in which the trench excavation is almost completely filled with concrete. Rubble trench foundations are a further variation of trench fill foundations and are a traditional construction method that uses loose stone or rubble to minimize the use of concrete and improve drainage. Pad foundations are rectangular or circular pads used to support localized loads such as columns. Raft foundations are slabs that cover a wide area, often the entire footprint of a building, and are suitable where ground conditions are poor. Settlement is likely, or where it may be impractical to create individual strip or pad foundations for a large number of individual loads. Raft foundations may incorporate beams or thickened areas to provide additional support for specific loads. Types of deep foundations include pile foundations are long slender columns typically made from steel, reinforced concrete, or timber. Piles are most commonly driven piles prefabricated off-site and then driven into the ground, or bored piles that are poured in situ. If the boring and pouring take place simultaneously, the piles are called continuous fight-legged CFA piles. Diaphragm walls are made by excavating a deep trench that is prevented from collapsing by being filled with engineering slurry, such as bentonite, and then the trench is filled with reinforced concrete panels, the joints between which can be watertight. This is commonly used for top-down construction, where a basement is constructed at the same time as above-ground works are carried out. Caissons are watertight retaining structures sunk into the ground by removing material from the bottom. Typically, this might be suitable for building structures below water level. The required depth of any foundation can depend on several factors. Soil bearing capacity. This determines how much load, weight, or force the existing soil can withstand. Soil type. Different types of soil have different properties that can affect their suitability for supporting a foundation. Frost depth. The depth to which the soil freezes in the coldest time of the year, known as the frost depth or frost line, often is used to determine the minimum depth for many types of foundations. Groundwater table. A high groundwater table can limit the foundation depth as well as the type of foundation that can be used. Minimum depth. Disregarding other factors, the minimum depth of a foundation typically is not less than 18 inches to allow for the removal of topsoil and variations in ground level. Foundations typically are built with masonry, such as concrete block or brick, or with poured concrete. Masonry materials offer high compressive strength and are much more resistant to damage from moisture and soil than wood and metal materials. A masonry foundation typically extends above the ground to protect other building materials from moisture and other damaging effects of ground contact. Masonry foundations are usually reinforced internally with metal rebar or other materials. Contractors will often use hydraulic cement to seal around pipes or raceways that penetrate the masonry or concrete foundation. Some building foundations are built with treated wood posts or piers. In this case, the foundation supports are driven deep into the earth and/or rest on rock or concrete pads. Posts and piers often are used when building on or near water or where the land is prone to flooding. In areas that experience ground freezing during winter, standard building practice has called for footings to be dug below the frost line to protect against frost heave. Such excavations can extend to more than 4 feet below grade. One of the most important foundation materials is the base or subbase of inorganic material laid directly under the foundation. In general, submerged soil and clay have limited bearing capacity and cannot handle the loads imposed by a building. Therefore, soils are dug away and replaced with a dry and uniform dense material, such as gravel or crushed stone, that offers maximum shear resistance and bearing capacity. Base materials also promote drainage of subsurface water and do not expand with high levels of moisture, as the soil does. Thank you for your attention, dear students. Next time we are going to study walls. See you next time. Goodbye.